we're going to solve now. We're doing systems, and one method of solving systems other than graphing is actually by doing something called substitution. Your first problem is 3x plus y equals 7. And 4x plus 2y equals 16. Guys, these two lines intersect somewhere, theoretically, right? Unless they're parallel, okay, or the same line. So we're going to figure that out. Are they parallel, is it the same line, or where do they intersect? We're going to do it by substituting. And before I start that, I wanted to ask you a question. On a side note, if I ask you to take 3x plus 2y equals 5, and for you to tell me what does y equal, is y 4, is y 7, is y 10, you can't tell me, can you? I can put y in terms of x. I can solve for y. But I'm still going to have an x in my answer, right? Versus if I asked you for a problem like this, could you solve for y this way? Absolutely. Combine the y's and solve for y. Right? So when you only have one variable, okay, then you're good. So that's what we're going to do. We're going to change it so that I only have one variable, and we're going to trade it out. Okay? So your first goal is to look for a variable, x or y, doesn't matter, that has no leading coefficient. Because if you don't have leading coefficient, the problem is much easier. So which of these? Line 1 or line 2? No, line 1. And what variable? Good. So then that's where we're going to start. We're not wrong or right by starting there. You can start wherever you want. It's just what we chose. So solve this for y by moving your 3x over. And what you just tell me right there is that now y is exactly the same thing as negative 3x plus 7. They're the same. Okay? And your goal now is everywhere we see y's, we're going to trade them out. And we're going to put in this negative 3x plus 7. Because if you'll put that in there, then you don't have to have any y's. Okay? And here's the mistake kids make. Kids try to take this line and put it back in. No, you can't do that. That's the same line. You can't put it back into itself. When you're substituting, you have to substitute it into the other line. Okay? So since y is here, so I'm going to take this y away, and I'm going to write it, and they call it in terms of x. Y is the same thing as this. So your next step is to take this 4x plus 2, and I'm going to change y to represent negative 3x plus 7. Now then, all we have are x's, and we can solve for x. So clean it up a little bit. 4x minus 6x. X has the answer of negative 1. So we're very close to there. We're halfway to your answer. They're going to intersect at negative 1 something. I just don't know what the something is. Okay? We're going to try to find it now. Now to find it, we need y. Okay? These two are exactly the same line written different. And here's my third line. Where's the easiest place to find y? A, B, or C? Where would it be? Is A, B, or C? It's B, right? Because it already says y equals. Okay, I need y. So let's take our negative 1 and say, okay, y equals negative 3, x is negative 1, so I'm going to trade it out. So now you have y equals 3 plus 7, so y is 10. So they intersect at negative 1, 10. And you can check your answer if you want. Watch. Plug in negative 1, 10 into here. So you have 3 times negative 1 plus 10. Does that give you 7? Yes. Now try the next one. 4 times negative 1 plus 2 times 10. Negative 4 plus 20 is 16. They work in both. Either way, it's fine. It's a good way to check your answer. All right, go to the next one. 2. Same directions. Solve by substitution. Do you remember what we did? What's our first step? Isolate, very good. Isolate a variable. There's no right answer here, guys. Which one you use doesn't matter. But in this case, there's only one easy answer. Let's isolate x in the second equation, right? Because it doesn't have what? Why did I pick that? It doesn't have a leading equation. Okay, so let's isolate x. My second step then is to take that and trade the second line out so that all I'll have is x's. So I'm going to pull this x out because I'm telling you x is the same thing as negative 4y minus 4. These are the same thing. So wherever I see an x, if I can just put this in there, I'll have no x's yet the same value. So I'm going to say, all right, 3 is negative 4y minus 4 plus 5y equals 2. Now then distribute and solve for y. You're halfway to your answer now. Y has a value of negative 2. That's 50% of your answer. Now we're going to take that and plug it back in and find x. So your answer is negative. Sorry. What's your answer? I wrote it backwards. Be careful. 4, negative 2. Got it? Okay. Those two are easy, right? Let's move to the third one. It's harder. On your test, just to give you a heads up, which, by the way, look up there on the board. What's your test? You're green. So it's the 8th. So Thursday, the 8th. Okay. So your test is Thursday. On the test, it will tell you guys, solve by substitution, solve by elimination, okay, solve by graphing. And then the third option is solve any method, which means you get to pick whichever method you want. All right? But you have to solve it the way it says for some of the problems. This problem, number 3, is a little harder to solve by substitution, but it can be done. 4x plus 3y equals 4, and then 6x minus 6y equals negative 1. What was step 1 in solving by substitution? Because that's the direction still. Isolate variable. Is there anything pretty? No. Does it matter where? Doesn't matter what line? Doesn't matter what variable. Okay, let's just all do the same variable. Why don't we start with the first line and isolate x? It makes no difference. You're going to get the same answer regardless. Okay, so let's isolate x right here. Which means we're going to want 4x equals negative 3y plus 4. Divide everything by 4, which gives me negative 3/4 y plus 1. That's your answer for the x being isolated. What's step 2? Yeah, can I plug it back into line 1 or does it have to be line 2? Yeah, when you are doing substitution, you have to plug it into the other line. It's got to go here. So 6, replace x with this. Why am I replacing x with that again? Can somebody tell me how come? What's my purpose? Why am I trading x out for negative 3/4 y plus 1? Yes, so that everything has only a y. Okay. This, I'm going to put this over 1, might help you, but I get negative 18 over 4. That reduces to negative 9/2. And then you got to go here, so plus 6. Minus 6y equals negative 1. What's my next step? Multiply everything. Well, you don't have to. But if you want to get rid of that fraction, you can multiply everything by 2. That's up to you. I'm going to choose that. So negative 9y plus 12 minus 12y equals negative 2. Let's combine the negative 9 and the 12 to give me negative 21y and move your 12 over. This is the reason. Look at the answer. What is it? 2/3. This is why you can't always solve them by graphing, right? Okay, 2/3 would be very hard to find the answer on the graph, wouldn't it? Now then, I have half my answer. So I'm going to take this part and plug it back in. So I know x equals, and you can plug it in anywhere you want. It's just this is easier because it says x equals. I'm looking for x. Negative 3/4 times 2/3 plus 1. Cancel. You get negative 1/2 plus 1. So x is just 1/2. Everybody okay so far?
Yeah.
Yeah? Alright, now let's move on. So we're done with substitutions. Let's create a new, be sure you highlight the substitution so you knew all those were substitution. And let's move to elimination. Elimination is actually my favorite. I prefer elimination. Even sometimes when substitution is maybe the best bet, I just prefer elimination. Okay, but they all work, and you'll have your own preference too. Okay, here's the first problem. Solve by elimination. 6x plus 3y equals 6. 8x plus 5y equals 12. Okay, before we start, let me ask you a question. If I have 3x and 3x, will they cancel each other? A plain 3x. What do 3x and 3x make? How many x's? 6. I don't cancel, right? How do I cancel one? What am I going to be able to do in order to cancel? One has to be a negative. Well, cancel and eliminate kind of mean the same thing, right? So your goal is to make them be able to cancel or to eliminate. So you need the same coefficient, but a different sign. Are you all seeing that? Okay. So if I take a look at this first problem, I need the x's to be the same and the y's to be the same. Okay. Anybody that's probably already done this before, what do you think I need to do here? Let's say I choose to eliminate y's. One's a 3 and one's a 5. What could they both be? 15. Okay, and if you're asking where I got that from, I'm just trying to find basically the least common denominator of 3 and 5. And if I take the top and I multiply it by a 5, then you end up with 30x plus 15y equals 30. Do you see how it's getting closer? If I'm choosing to eliminate y, what would I need this to be? 5, I need to change 5, so it's going to be not a 15y, but a negative 15y. So what do I need to multiply that second equation by? A negative what? A negative 3. It's going to give me negative 24x minus 15y equals negative 36. And draw a line and add the two together. What do you notice about the y's? What happens to them? What's 15 plus negative 15? They cancel. They're gone. I eliminated them. So now then you end up with 6x equaling negative 6. So x is negative 1. Here's half my answer. Now, put your pencil down, listen to this sentence. In substitution, you always had to substitute into the second line, right? You solved for a variable, put it in the second one, or the other one. Here, x is negative 1. Okay, right here. It does not matter where I can put it into this line, this one, or the last. They're all the same. Okay? These are just different forms of the same line, and these are different forms of a different line. Makes no difference because negative 1 is the intersection. It works with both lines. It's the answer. So it makes no difference where you plug it in to get y. I'm just going to pick this first line right here. So 6 times negative 1 plus 3y equals 6. This is a negative 6. So add 6 to both sides, and 3y equals 12. Y is 4. So your word pair that works is negative 1, 4. By the way, out of curiosity, how do I classify that using like the proper terminology? Is it consistent or inconsistent? Consistent as solution. Are they independent lines or dependent lines? Dependent. There's only one solution, remember? Independent. Make sense? Okay. Next one. Again, solve by elimination. Okay, it's elimination. So, I need them to, the x's need to be the same and the y's need to be the same. If I was going to get rid of the x's, what would I need to change this 2x in order for it to be a 4x, right? A negative 4. So it would be negative 2. If I chose y's, what would the y on the bottom right here, this y, what would it need to be? It need to be a positive 2, so I have to multiply it by negative 2. Okay, so what do I need to multiply by then? Negative 2. So the top one, let's leave the same. And the bottom line, let's multiply by negative 2. Which something strange happens. What happens here? Yeah, they both cancel. So on the left you have nothing, and on the right you have 7. What does that tell us? Think about it when you get answers like this. What? Okay, no solution. What does that mean? What kind of lines are these? Do we need a graph to decide that? No. Do we need them in y-intercept form to decide that? No. See how smart you're getting? You didn't even need any of that. You didn't need to even know their slopes to know that they're parallel. Okay? Lots of different ways to decide if things are parallel. Right? But yes, they are parallel. So there's no solution. Now, guys, in terms of classifying them, what would they be classified as? Consistent or inconsistent? Inconsistent, yeah. The directions didn't ask for that necessarily, but you'll be required to do it on the test. You need to know. It's good practice just to think about it. Number 3. 2/5 x minus 1/2 y equals 6. And then you have 4/5 x plus 3/2 y equals negative 8. Two ways of looking at this. What can I multiply by my top row by to cancel the y's? If I want to cancel the y's, I multiply it by what? 3. If I wanted to cancel the x's, what would you multiply by? Negative 2. Another option is to get rid of your fractions. Raise your hand if you want to get rid of fractions. Let's see the choice here, so I know which way to go. Okay, raise your hand if you just want to multiply it the way it is. Who votes for that? How many of you don't care which way? Okay, the don't care is one. So then let's just get rid of the fractions. If you don't want to get rid of the fractions, try it your way and see if you get the same answer. Multiply by 10, both of them, which gives you 4x minus 5y equals 60. And then 8x plus 6y equals negative 8. Now then, to simplify, it depends on which way you go. Well, this should be 15y. You can either multiply to get rid of the x's and use negative 2. Or to get rid of the y's, you can use positive 3. Let's do the y's. Which means the second row stays the same. You don't have to multiply both rows. These cancel and you get 20x equals 100. X is 5. Agree? Now, where you find y doesn't matter. There's 6 equations here. You can use any of them you want. Because that's an answer, right? Why don't we use, it doesn't matter. You can use this one. 2/5 times 5/1 minus 1/2 y equals 6. This value is just 2. You subtract your 2, you get negative 1/2 y equals 4. So multiply by negative 2/1. So y is negative 8. You may do it a different way and still get the same answer?
Yeah.
Yeah, it should be the same. Okay, number 4. We'll give you some time to try that one. This one's the last one we're doing. If you multiply the top row by negative 2, what happens?
Everything cancels out.
Mm-hmm. What do you think that means? I hear it. Yay. What's it mean? Same line. Okay, what kind of answers does that tell us? What answers work? How do we write the answers? Is the answer all real numbers?
No.
No. But it's an infinite number, right? Lots of answers. How do we write it?
Set filter.
Yeah, good. Set filter. So we're going to say, all right, every point such that, all x, y such that it's on the line. Which line you use, it doesn't matter. I'm just going to use the first one. Do the same line. And then my next question to you is, how do we classify this? Is it consistent, inconsistent? Which one? Consistent, because it has an answer. And then what else? Dependent or independent? Dependent. Excellent. Good job, guys.